Welcome to the deep dive. Today we're looking at something really fascinating in the world of large language models.
hmm
It's this puzzle, right? How do some of these smaller AI models manage to perform so well, without needing absolutely massive computing power?
Yeah, it's a great question.
So we're going to unpack a technique called knowledge distillation. It's basically the secret sauce that helps make AI powerful but also practical.
That's a good way to put it. At its core, we're talking about how the knowledge or the capabilities of a really big AI can be sort of transferred into a smaller, more efficient package.
Like a teacher-student thing.
Exactly like that. Imagine you have this genius level expert, understands tons of information. Knowledge distillation is like teaching a bright student the key skills from that expert.
So the student can do the job well, but maybe more efficiently.
Precisely. Without needing all the resources the original expert has.
And this is really relevant, isn't it? I mean, if you've ever wondered how complex AI stuff runs on, say, your phone without just killing the battery, then understanding knowledge distillation gives you some real insight into how that's even possible.
It really does.
Okay, so let's dig in properly. What actually is knowledge distillation in, more technical terms?
Okay, so formally, knowledge distillation is a training technique. You take a large, complex model that's the teacher, which already performs a task really well,
Right.
and you use its knowledge, its outputs, to train a smaller, much more efficient model, the student.
And the main aim.
The goal is to get the student model performing almost as well as the teacher, but with way less computational cost, lower latency, faster response times.
So it's not just about making the model smaller, it's about cleverly passing on the important stuff. Like our expert teacher isn't just dumping facts, but teaching the core ideas, the effective strategies.
Exactly. So the student can handle real problems effectively, even if it hasn't memorized every single tiny detail the teacher knows.
Makes sense. The teacher knows everything, maybe too much for everyday use.
hmm Can be cumbersome, impractical sometimes. The student learns the crucial insights from the teacher and becomes, well, more agile, easier to deploy.
And you mentioned it might even generalize better sometimes.
Yeah, that's a fascinating aspect. Because it's forced to learn the most fundamental patterns, sometimes the student can actually adapt better to slightly new situations than the overly complex teacher.
Okay, interesting. So let's apply this to large language models. We hear about the giants like GPT-4, LLM-2. How does this knowledge transfer actually work for them? It's complex, generating human-like text and all that.
It is complex. And yeah, those teacher models are huge. Billions, sometimes trillions of parameters. Those are the kind of internal knobs the model tunes during training.
Right.
So to distill one of these, you take the big teacher model and use its outputs to train a much smaller one. Something like Tiny Llama is a good example. Much, much smaller parameter count.
Tiny llama. Yeah, the name gives it away. So the big model is sort of coaching the little one.
Coaching is a good word for it. The student gets fed similar or often the same input data as the teacher. But here's the key difference.
Okay.
Instead of just learning from the correct answer label, the student learns from the teacher's soft predictions.
Soft prediction. Okay, that sounds important. So it's more nuanced than just right or wrong.
Absolutely. Think of soft predictions as probabilities across all possible answers. So instead of the teacher just saying the answer is apple, it might say apple is 95% likely, pear is 3% likely, orange is 1% likely, and so on.
Ah, okay. So it's giving the student a richer picture.
A much richer picture. This extra information helps the student understand the relationships between different concepts, the subtleties.
Right. Let's really unpack that soft targets. Why are they so much better than just the standard hard targets, the single right answer?
Well, the key is the implicit knowledge they carry. A hard target just gives one correct point. Aim here.
Right. Binary.
Exactly. Soft targets, though, they show the teacher's confidence levels. And they also hint at which other answers might be plausible, even if they aren't the top choice. It's like the teacher isn't just giving the answer, but showing its work, its thought process.
Can you give us a concrete example? Make it really clear.
Sure. Let's say the task is finishing the sentence. The weather today is. A big teacher model might predict sunny with 80% probability, cloudy with 15%, rainy with 4%, and so on.
Okay.
A hard target would just be sunny. That's the correct answer in this case. But the soft target tells the student sunny is most likely, but hey, cloudy is also quite possible. And even rainy isn't completely out of the question.
So the student learns not just sunny is common, but also learns about other weather types and their relative likelihood in that context.
Exactly. It learns context variability, which a simple sunny label just wouldn't convey.
So the student isn't just like pattern matching the most frequent word, it's getting a deeper sense of the probabilities, the relationships, picking up the teacher's intuition.
That's a great way to think about it. Intuition, yeah. This richer signal from the soft targets helps the student model grasp more complex patterns. It learns not just what's correct, but how correct and what else is reasonable. You end up with a smaller model that's surprisingly robust.
Yeah, that makes a lot of sense. Okay, so pulling back a bit, what are the big wins here? What are the tangible benefits of using knowledge distillation? Why not just train a small model from the get-go on loads of data?
Well, the advantages are pretty significant, especially when you think about actually using these models in the real world. First off, the student models are just much, much smaller, fewer parameters,
Right, smaller file size.
smaller size, which directly leads to faster inference speeds. They can generate answers or process text much more quickly.
Faster and smaller. That sounds like a winning combo for, well, pretty much any application.
It really is. And because they need less computing power, less memory, they become much easier, much more practical to deploy in different places.
Like where specifically?
Think about running AI directly on your mobile phone, or in embedded systems, maybe in your car, or smart devices. Even web applications where you want quick responses without huge server costs.
And training a small model from scratch wouldn't necessarily get you there.
It's much harder. You'd often need vastly more data and much longer training times to get a small model trained from scratch to reach the same level of performance as a distilled student model. And even then, it might not capture that same nuance learned from the teacher's soft targets.
Ah, okay. So distillation is really a key step for getting this advanced AI out of the lab and onto the devices we actually use.
Precisely, it's like a bridge. It lets us take the power of these enormous cutting-edge models and package it for situations where speed and efficiency are crucial. It makes powerful AI more accessible, more democratic in a way.
Okay, let's try and bring this to life even more. Can you give a really concrete use case where knowledge distillation is making a tangible difference right now?
Yeah, absolutely. A very common one is developing mobile apps that need some kind of LLM capability, maybe an intelligent chatbot within the app, or real-time text summarization, or maybe some creative writing assistance features.
Right, stuff you want to work instantly on your phone.
Exactly. Now, imagine trying to put a full-size model, say like a 13 billion parameter LLM model, directly onto a smartphone.
Forget it, it would be huge. Drain the battery in minutes, probably run incredibly slowly, if at all.
Exactly. It's just not practical. The storage requirements, the computational load, the power consumption, it's too much for a mobile device.
What?
But a distilled version, like our Tiny Llama example, which might be derived from a larger model but is much smaller and optimized, that becomes totally feasible. It
Ah.
can perform many of the core language tasks, maybe not quite as perfectly as the giant teacher on every single metric, but really well, and it can run efficiently on the device.
So you get that smooth, responsive user experience. The AI feels like it's part of the app, not something you're waiting ages for.
Precisely. And that's happening now. It's enabling much more sophisticated AI features directly on phones and other edge devices without needing a constant connection to a massive cloud server for everything.
So yeah, I could have a genuinely smart AI assistant or feature in an app right there in my pocket, and it doesn't turn my phone into a brick or a heater. That's actually a huge deal.
It really is a huge deal. Knowledge distillation is, well, I'd say it's a pivotal technique. It's fundamental to making advanced AI capabilities much more widespread, more ubiquitous.
By letting this powerful models run on all sorts of devices.
Yeah, by expanding where sophisticated language models can be deployed, it massively increases the potential usefulness and impact of AI in our everyday lives.
Okay, so just to wrap up the core idea then, knowledge distillation is this really important process. You take the huge knowledge base of a massive AI model, the teacher,
Hmm.
and you cleverly transfer the essential parts of that knowledge into a much smaller, faster model, the student.
Right, making it more nimble, more deployable.
It's like our expert teacher focusing on the absolute key lessons so the student can go out and, effectively use that knowledge in the real world, even without the teacher's giant brain or library.
That's a really good summary. The teacher model provides the foundation, the deep understanding, and that enables the creation of these student models that perform remarkably well, even when resources are tight. It just opens up so many more possibilities for AI applications.
It really does, and it makes you think, doesn't it, about the future. If we keep getting better at this, at making AI smaller, faster, more efficient through techniques like distillation, what new things become possible?
Yeah, what happens next?
What kinds of applications or experiences could we see if sophisticated AI can just run seamlessly on pretty much any device around us? It's definitely something to ponder. Thanks. This was really illuminating.
My pleasure. It's a fascinating area.